Now, to start our geometry journey, we're going to start with the most basic concept, and that is the concept of a point. A point you can think of as just a location. We describe a location and then we name that location. So, for example, we have some points here on this grid, and I have point A, B, a point C, a point D, a point E. So here's A, here's B, C, D, and E. And we want to think of a way, first of all, we want to think of a way to describe that location, and then we want to have a way to name it. Now, usually we'll name a location with a capital letter. In this course we will, and we'll talk about A, point A. So I've got this point A here, and what I want to do is talk about, well, where is A on this grid? I have the x-axis here, the horizontal direction, and the vertical direction here. Now I realize, so I'm going through this kind of fast because I realize that in Algebra 1, you've covered this before. You understand the XY plane. So here's what we've got. I want to know how to describe this. Well, how many units do I go on the x-axis? And you can see I go 1, 2, and then how many on the y? 1. So we would talk about this point as being 2, 1. And notice that both coordinates, the x and the y coordinate, are both positive. Now, I could talk about, well, what about B, that point B? Well, here I'm going to go over 5, 1, 2, 3, 4, 5, and then up 5, 1, 2, 3, 4, 5. So that point right there would be 5, 5. Okay, now let's look at C. I'm going to go over 3 to the left. Ooh, if I'm going 3 to the left, that's going to be a negative, but then I go up 3 for the y. So that's negative 3, 3. As far as D goes, I'm going to the left 1, so I go down 1, see, down 1 right here. And then I go down 1, 2, 3, 4. So I go left 1 and down 4. There we go. Okay, so that's that point. Now as far as E goes, I go 1, 2, 3, 4, 5, 6. So E goes like this. I got 6, comma. Now I'm going in the vertical direction down, so that would be a negative 2. So this is the way I can talk about these points. I can name them. And remember, points are just a location. Now, what we can do with points, though, is we can we can expand on it and say, well, let's talk about a lot of points that have something in common. For example, a line segment. This thing right here, A, B, this right here, that's called a line segment. It starts at A or B, it doesn't matter which, but it has an endpoint of A and it has an endpoint of B, and then in between are just an infinite number of locations between A and B. And these locations are straight. It's like if you put a ruler there on A and on B and just drew a straight little line up there. That would be a line segment. And we name that AB with a little line above it. That indicates that set of points. In other words, that little part of a line. But really, it's a whole bunch of points that form a little segment there, a solid. Now, actually, I'm going AB, but you could name this BA. Can't think of any reason why you couldn't name it BA. You just have the endpoints, and then it's understood with that little line above it. You're talking about all the points in between. Now, down here for AE, you've got AE, little line above it, or you could say EA, little line above it. It really doesn't matter on these because there's not a direction. Now, then over here, you've got CD or DC. Yeah, there you go. But that's how you name those segments. So we have points, then we have line segments when we draw a line between those points. And that line represents a union of all the points in there, all the locations between A and B that are on a line. Now, if you look over here to the next part, we have what's called, we have what we're going to call rays. Okay, so these are R-A-Y-S, rays. And they do have a direction. Notice that this first one, it starts at A, it goes through B, and above it, we just put a little arrow like this. And that is how we talk about a ray. Now, to say BA and a little arrow above it would not be correct in defining this particular ray here. Because it starts at A, and then it indicates the direction by going through another point, and then this little arrow here indicates we're going forever in that direction. If we had BA, it would look like this. Okay, BA would have a point here, and it would go like this. Okay, it would go in that direction. Okay, but and then it would be BA. So with the rays, it's important which way you point, what letter you put first. Now over here, it's going to be AE. And I put a little arrow above it. Okay? Because we start at A and we go through E and go on forever in that direction. That's a ray. Over here, we've got CD. Put a little arrow above it. Okay? Now, those are what we call rays. Now remember, if you have something like this, so let's suppose you start over here at H. Here you have K. This would be HK. If you go the other direction, where this is H and K is down here, then that would be KH. So the direction matters on these rays. Now let's suppose that you put a couple of rays together. In other words, let's suppose that you put this ray together with this ray. Okay, in other words, you've got this ray, and then you put another one right here going just in the opposite direction. That, and you're at a point here, that would indicate a line. It's a line that passes through this point and goes forever up this way and down this way. That's what makes a line. And a line is lines are what we're going to focus on primarily in this video. But here you have, this first one, you have a line AB. So it'd be A, B, and you put a little double arrow above it. And here order doesn't matter because we could write this as BA if we wanted to. Okay. You just put the arrows, a double arrow little line above each one. So that would be that one. Now, if you're talking about the red line, you've got AE, put little ones of these, or EA. There we go. And then finally for the green, you've got CD or DC. Okay? And the order doesn't matter on these. Okay? Okay. Now, we're going to take a minute and really focus on lines. And in fact, I want to focus on, to start off with, this line right here, AB. So AB, I'm going to call this line AB. And what we want to focus on with this line, we want to focus on what point the line passes through and how steep the line is. So those two things are what we want to focus on. So notice on this one here, this line passes through A, and then it has a certain steepness to it. So I want to take note of that. I want to just take note of the point. The point that this line passes through. Of course, it passes through B as well. But notice it points through point A, which is 2, 1. And it passes through B, which is 5, 5. Okay? Those are the 2 points it passes through. Now, what I want to know is how steep is that line? Now, here's the thing. Anytime you have 2 points on a plane, you can define a line that passes through those points. In other words, there's a line that passes through any 2 points you can draw. There's going to be a line that passes through them. Now, and we're going to define them by, we need 1 point, either A or B, and we need to know the steepness. Now, let me show you how we're going to determine the steepness. Notice that to get from A to B, you're going to have to do something horizontally. You're going to have to go to the right, 1, 2, 3 units to the right. Now, I'm calling this quantity here delta x. Okay, so I'm going to call that delta x. And delta x here is 3. That's how far we need to go to the right. Now, then to get up to B, we're going to go from there. Let's see how far we go. We go 1, 2, 3, 4. Okay, so from A, we go over 3, delta x. And then from there, where we're right under B, we go up 4. So I'm going to call delta y 4. Okay? Now, we want to put those together. In other words, what I want to do is I want to say, okay, for a given change in the x, how much change do I have in the y? We call that the slope. So we have delta y over delta x. So this is going to be 4 over 3. See? Okay. In other words, the slope is how much does y change for a given change in x? Well, for every 3 units you go to the right, you go up 4 units vertically. So 3 units to the right, 4 units up. And that's the way it is for every point. We call that the slope. This is the slope. Now, you can find the slope. You may have seen this formula before back in your Algebra 1 days. The slope is the difference of the y's. So we've got 5 minus 1. Okay? Because this point, you go the difference of the y's. This y minus this y over, this x minus this x. And you get 4 over 3. There is your slope. Now that slope is going to be the same for points for any 2 points. So let's suppose you've just got some other point here. Let's suppose I've got a point right here. And I'll call this point x and a y, like that. Okay? The slope is going to be this. It's going to be the difference of and remember this point down here is 2, 1. So the slope is going to be y minus 1 over x minus 2. See? Because now I'm dealing with not this point up here, but just any point on the line. X, y is on that line. So there is my slope. That's a formula for the slope. Now dig this. I'm going to do this. I'm going to take this thing and I'm going to multiply both sides by the denominator. And I can do that. This is an equation. So dig what I've done here. I've taken, let me see here. I've taken I've multiplied this side over here with x minus 2, and I've multiplied this side over here by x minus 2. I can do that. That's because I've got an equation there. And dig this. When I do that, the x minus 2 divides out over here, and look what I've got. On one side of the equation, I've got y minus 1 equals m times x minus 2. And there it is. This is the point-slope form of a line. This is an equation for the line. So if you put this in your calculator or in Desmos or any other graphing program. Now, so let me show you. Let me see if I can, let me click on this link up here, open. And let me see if it, there we go. Okay, so look, I'm going to write that equation here. So I have a y minus 2 equals 4/3, and I'll just type this in. And actually, wasn't it y minus 1, I think? And then this is x minus 2. So notice, all I did was I just entered that equation that we just got. Now I've got this point 2, 1, and 5, 5. Notice I've got those. And now let me turn these points off. And notice there is my line right there. Okay? So I've got point A and point B, and I've come up with an equation for the line that passes through those points. Okay? So notice what we need. We needed a point, and let's see what we've got here. I've got a point. The point I used was A. Okay? So dig this. I got this point, A, and then I need the slope, which is 4/3. Now, let's look at this. Let's just do a few practice here. Okay? I've got a point. I've got 1, 2, 3, and 2. So A is the point 3, 2. Now let me get the slope. Let me figure out what B is. B is the point. I've got 3, 4, 5, 6, and 1, 2, 3. 6, 3. Okay? Now notice I could just say, okay, well, this is 1, 2, 3, and then up 1. So I know for sure that delta x is 3 and delta y is 1. See? Because I go to the right 3, 1, 2, 3, and then up 1. And then, and the delta y is 1. So my slope, I know right away, is 1/3. Now, we could also get the slope this way. The slope is equal to 3 minus 2, see the difference of the y's, over the difference of the x's. And that's 1/3. See, so here's 1/3, here's 1/3. Now, we pick a point. Y minus the y coordinate equals 1/3 times x minus the x coordinate. And there's my equation for the line right there. Yeah, that's it. Okay, now let's look at this next one. I've got the point A. Let's see what this one is. 1, 2, 3. So this is 3 units to the left and then up 2. That's that point. B, this one is 1, 2, 3, 4, and down 2. So this is over 4 and down 2. See? So that's the location of those points. Okay, so 1, 2, 3, and up 2. And then 1, 2, 3, 4, 5. 4, sorry about that. And then down 2. Okay, now, I got 2 points, I only need 1. But let's just see what the slope is. To get to this B down here, I need to go to the right. 1, 2, 3, 4, 5, 6, 7. I go 7 to the right, so that's delta x. And then how far down do I go? 1, 2, 3, 4. Delta y is -4. There we go. So I know right away from that my slope is going to be -4/7. See? Because I go this way. From this point A, I go 1, 2, 3, 4, 5, 6, 7. And you always move to the right. And then it's either up or down for the y. And then I go 1, 2, 3, 4. So down 4. So my slope is -4/7. Now, let's just use the slope formula. The slope formula says this. I've got to take a difference of the y's over a difference of the x's. See? There we go. You got to watch the signs here. So this is -4/7. -4/7. Oh, so now let's see what we've got. Y minus 2 equals -4/7. X minus a -3, which would be x plus 3. So y minus 2 equals -4/7, x plus 3. And there's my equation right there. That's the equation for the line. So if you draw a line through here, I'll go ahead and expand it out. Whoops. There we go. The equation for that line is this bad boy right here. Okay, now let's look at this next one. We're going to start down here at A, and let's see how we get up to B. We go 1, 2, 3, 4, 5, 6, 7, 8, 9. Delta X is equal to 9. And then going up, we go 1, 2, 3, 4, 5. Delta Y is equal to 5. Notice we're going to the right, and then we go up. Okay? So I know my slope is going to be 5/9. Now really, I just need 1 point. And I think I'm going to use B as a point this time. I'm going to go 1, 2, 3, 4, 5. So B is the point 5, 1, 2. I'm using B because it's both numbers are positive. So here's what I got. Y minus 2 equals 5/9, x minus 5. There we go. Yeah. So I didn't even need to calculate the point A, what it was. I didn't care what it was. Okay? But that's how you can calculate. That's how you can come up with the equation for a line. You need 1 point and you need the slope. Now, I want to look at something else here. I've got 2 graphs here. I'm going to focus first of all on this one right here. And I want to show you another way to represent a line. And I'm going to show you how to do this parametrically. Now, this is something that you may not have seen before. But let's just look and see how this looks. I'm going to start here at this point right here. This is 1, 1, okay? So I've got this point 1, 1. And I want to know, well, how do I get up to this point over here? Well, I'm going to go over 2, 1, 2, and then up 3. Okay? So it looks like delta x is 2, and it looks like delta y is 3. Okay? Now, from here, notice I go over 2 and then up 3 again. Okay? I go over 2 and up 3 again. Over 2 and up 3 again. So, look, here's what's happening. Think about this. We start off with this point, and I'm just going to look at the x's, okay? So here's what's going on the x coordinates. We start off with 1, and we add 2 to it, right? See? I start off right here, and I add 2. Now, that takes me to this point right here. I didn't do the y's, but how do I get to the next one? Well, I add 2 more to that. See, from here, I need to go 2 more. So to get to the next point, I've got 1 plus 2 times 2. See? And that will take me to this point right here. Then how do I get to this next point? Well, I have to go 2 more to the right. So that's 1 plus 3 times 2. See? So here's 1 times 2, 2 times 2, 3 times 2, and then 4 times 2, 5 times 2, and so forth. You see, what I'm doing is I'm looking at this a little differently. I'm saying, okay, if you start at any point, now bear with me here. I'm starting right here. How do I get to another point on this? Well, I need to add 1 times the delta x. So this is 1 plus delta x. How do I get to the next one? Well, I add 2 onto that. Okay, so I add 1 plus delta x plus another delta x. So now I've got 1 plus 2 delta x. Okay, and then the next one, I go 1 plus 3 delta x, and then 1 plus 4 delta x. Okay. And in this case, the delta x is 2. Okay? So look what I could say. I could say that if you have an x-coordinate on this line, you're going to start at 1, and you're going to add to it the delta x, which is 2, times some number, which I'll call t. See? Here's 1 plus delta x, which is 2, times, t. Okay, so let's see how this looks. We have 1 plus 2 times 1. See? 1 plus 2 times 2, which t would be 2 in that case. 1 plus 3 times 2. Okay? See? T would be 3 in this case. 1 plus 4 times 2. T would be 4 in that case. You see how this looks? Okay? So we have an x value and then the 2 times t. Okay? In other words, that will get you to any point on here. So let's look at these points. We start off with 1, 1. Now this next point over here is 1, 2, 3, 1, 2, 3, 4. So this is 3, 4. So how do we get to that point? Well, we have 1 plus 2 times 1, and that's 3, right? That's how we get that point right there. Okay? This point, if we start off with t as 0, we would get 1, 1. And what's this point over here? Well, this is the x-coordinate's 5, and this is 5, 6, I guess this is 7. Okay? So we got 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7. Okay? So now think about this. What if t is 3 or 2? Well, we've got 1 plus 2 times 2, and that would be your x-coordinate, so that would be 5. See? That matches there. Okay? So now this is the x-coordinate. Now let's see if we can figure out what the y is. Well, we start off with the y to be 1, and we add to it. Okay, so here we go. We add to the y's. So the y is 1. Now to get to the next, to get to the next y, we're going to add 3. Okay, so we add 3 and let's just go ahead and put this a t. Now, so look here. When t is 0, we've got 1, 1, this point right here. When t is 1, what do we get? We get 4. So let's see here. 1, 2, 3, 4. Look at that. When t is 2, we get 7. So let's see here. 1, 2, 3, 4, 5, 6, 7. So look, we could view this line parametrically as 1 plus 2t, comma, 1 plus 3t, where t starts at 0, and I don't know, it goes maybe 10 or something. And that would be a representation of this line. This is the parametric representation of the line. Yeah. So let me show you how this works. Okay. Now, this is not a typical geometry concept, but I want to. But y'all are smarter than typical students. So I want to show you how this works. Let me just give you a summary. So here we go. I'm going to look at this point right here. I start off at 1, 2, and then and this goes up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we've got this point 2, 13. Now, to get from this point to this point, what do? You go over 2 and down 3. So delta x is 2, delta y is negative 3. Here is the parametric form. 2 plus 2t, see, delta xt, and y is 13 minus 3t. And t goes from, let's say 0 to 10. Okay? I'm just using 10. It's kind of random, but I do want to start at 0. Now, this will give you all of these points. So, for example, if t is 0, you've got 2, 13. What if t is 1? Well, then you've got 4, 10. And let's see if that's a point on this line. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. And as you increment the t's, you get a point on that line. Now, the other way, this is the parametric representation, and we call it parametric. Now, we also have the old way, y minus 13 equals negative 3 halves x minus 2. This is the standard way of writing the equation for a line. And notice I just put the dy, delta y over the delta x. And I have my point, 2, 13. Yeah, that's it. Okay, so what we want to do then is I would like for y'all to work through these problems. You need the standard equation for the line and the parametric form of it. And then, I noticed here that, I noticed that I left something off here. This should be why not. I left that off. Okay? So, now, you may have questions about this. But remember, that's what I'm here to help you with. I will help you with these questions. So just take this 1, 2, 3, 4, 5, 6, those 6 problems, and for each one of them, you'll have this equation, and then you'll have a set of parametric equations like this. And we'll work on this. You'll get this. But just give these a try, and then we'll talk about them.